Hi, we've got some viewers. My first time using Google Hangout from this point of view, so I'm poking around trying to figure out how to do what I need to do. All right, so we're up to 3 viewers. Can you hear me? Is my microphone working? Down to 2 viewers. Can anybody hear me? I cannot. Cannot see the live chat. There we go. Now I can see the chat, and I can do what I need to do. Let's pop that out, make that bigger. I will try to keep an eye on that. All right. So we've got, switch back to the other one somewhere. All right. We have infinity. Can you see my screen? It'll be a little while before you can respond. So we're getting set up here. We have, I'm going to stop that for the moment. All right. We've got that. Cool. So we've got 12 people. You can see me. I can't see you. So we're good thing the main topic isn't scheduled to start till 6:30, so it only took me 14 minutes to get hooked up and ready. Michael couldn't make it tonight. He is on the road. He's currently pulled over at a rest area and he's on briefly. But he has to get back in the car and leave soon. So he put out the word and I volunteered. My name is Tim Curwick. I am a PowerShell MVP. I run the Minnesota PowerShell user group. If any of you are further up north than you probably currently are, although I see at least one Minnesotan on the line. I am an automation consultant with RBA up here in Wayzata, Minnesota, and currently working at one of the large enterprises in the area, doing a bunch of PowerShell work, automating against Power BI, some of the admin functionality that isn't built into their PowerShell module yet, and for which the UI is inadequate in a large enterprise. So that's always fun. We have, so I don't know what to talk about for the next 14 minutes until I start talking for real on my lecture, but I can always talk about anything. As who am I talking to? What's my audience? Can anybody give me a clue as to what you do and what you do with PowerShell and what you're interested in and how I can help? Our main topic tonight is going to be error handling and logging, which I believe is a very useful lecture for anybody and everybody that absolutely can improve any script and take us to the next level so that we don't have to do any work. Windows sysadmin. That's where we all start. Why we all start in PowerShell. Let Windows do the work. Chicago. We've got a mix. I'm guessing you don't usually drive down to St. Louis and that you're here just for the one. That's the joy of virtual, so we can get a very varied audience. And Minnesota group, we never do virtual because we feel that if you're willing to go for a virtual group, then you don't have to go local. You can go anywhere. The Mississippi PowerShell user group meets on the same night as the the Minnesota group meets locally, and they're entirely online, and they're a great group run by Mike Robbins. And so on Patch Tuesday, if you're looking for a virtual meeting, that's a good place to go. Search for them. If you happen to be in Minnesota on PowerShell Tuesday, come see us. We meet at Microsoft in Edina, a suburb of Minneapolis. And but we feel that our value add is being local and in being able to have that give and take between the speaker and an audience, and in the networking. The last 4 or 5 jobs that I've had have been through the PowerShell group or other user groups in the area. So local user groups are very helpful in many ways. And an awful lot of what I've learned through the PowerShell group or through speaking at PowerShell groups. You learn a lot when you have to figure out something well enough to be able to actually sound like you know what you're talking about when you talk about it. Might have, if I'd been thinking ahead, might have been able to come down to St. Louis for last month's meeting. I was passing nearby on my way down to Alabama for a YouTube creator conference that I went to. That was fun. Anything that anybody would like me to talk about for the next 10 minutes before we get into our main topic? PowerShell resources. And if anybody has any recommendations for PowerShell resources, I'd like to hear them. I just get to hear stuff from my local group, and it's mostly stuff that I told them. And I wish that's one reason I wish I was on site. We could have some back and forth, as I'd like to get some feedback from people who didn't learn their PowerShell from me, and so they have a wider experience of what can be done and how to do it. If you're looking for other PowerShell resources, the PowerShell Slack is awesome. Although Mike's on there all the time, so Mike Lombardi, he's probably told you about that. Then you go to, I don't remember I've got links somewhere. I can post them later. There's a place you can get an auto invite to the PowerShell Slack, and then but you can also access it through other sources. There's a bridge to IRC and a bridge to Discord, and I think a couple other platforms. And there's always a great group of people talking PowerShell there, and usually a lot of PowerShell MVPs and sometimes Microsoft PowerShell engineers wandering through. If you like forums, which are awesome for feedback, PowerShell.org has great forums, a lot of MVPs and a good community. And the nice thing about forums is when you sit down and start to write out what your problem is, and you have to articulate what you're trying to do, what you tried, and what went wrong, 9 times out of 10, you figure it out, and you never even have to post the question. So that's one of the great things about forums, and going for that help is most of the time you don't even need it, but just being forced to articulate it makes a big difference, and being forced to think about what types of questions other people will ask if you ask them for help. Hello, nerd. That doesn't exactly distinguish you in this group, but it's we all need good screen names. Yeah. The other good source is the PowerShell Reddit. If you like Reddits, that's really good. If you're looking for books, the most popular PowerShell book out there is PowerShell in a Month of Lunches by Don Jones. It's the biggest seller. It's not my favorite. Part of that, just because it teaches old school thought processes and learning processes, and it starts you off teaching you things that aren't the best things to start with in order to learn good PowerShell practices. My favorite book is PowerShell in Action by Bruce Payette. And it's awesome, and it's thick, and a whole lot of information, and a lot of really good information, both for beginners and advanced people. Goes really in depth and gives a lot better understanding of what's happening. Bruce was one of the original architects of PowerShell, and is still an architect of PowerShell. So, Jeffrey Snover had the vision of what PowerShell was supposed to be able to do, and Bruce Payette was probably the primary lead in deciding how to actually do that. So, the syntax of the language and how we use it. Most of those decisions came from Bruce, so he really understands why things are the way they are, why trade-offs were made, and what's happening underneath the covers in order for stuff to happen. So that's a really good book. And if you're looking for advanced PowerShell books, of course, you got to read my book and Mike's book. Mike's in there. Mike, you wrote a chapter there, right? The PowerShell conference book, which is just an awesome book. 33 different top MVPs. Oh yeah, so the 33 PowerShell MVPs each wrote independent chapters on intermediate and advanced PowerShell topics, and it's a really cool book. Get it on Amazon or leanpub.com. I recommend getting it from leanpub.com. The hard copy is huge and unwieldy because it's a big book, a lot of good information. And it's in black and white. When you're looking at code, it's a lot nicer to have color. And it's a lot easier to copy and paste from an ebook than a physical book. And all the proceeds go to charity. We don't get any of them, but so it's not like it's not a shameful plug to Michael. So it is a shameless plug. There's nothing wrong with plugging the book. It doesn't help us any for people to buy it. It's supposed to help them, and that's why we advertise it. Ooh, and we got .NET developers in the house. Those guys. Oh, hey, somebody actually bought the book. Cool. Not a lot of people have. We sell about 1 copy a week now. Sold about 300 when it first came out, and about 1 copy a week since then. On LeanPub, I don't know what we sell on Amazon. They don't give us the updates on that one. The other reason to buy it on LeanPub is you want the money to go to charity. LeanPub takes 20% of the cover price. Amazon takes 53% of the cover price. So a lot more money goes to people that it should go to, and not Jeff Bezos if you buy it from LeanPub. Ooh, another .NET developer. Bum, bum, bum. Yeah, .NET is volume 2. Yeah, Mike's yeah, you guys can read the chat. I've been talking to, he's probably, I'll let Mike handle that. Now I confused myself. What was I talking about? Oh, I was going to make fun of .NET developers. Yeah, it's always interesting to look at code and be able to instantly tell that it was written by a developer and not by a scripter, because they like to do things the hard way. And one of the advantages of PowerShell is that it is incredibly flexible, and it lets you do things the way that you did them in whatever language you came from. One of the disadvantages of PowerShell is that it's flexible. It lets you do things the way that you did them in the language that you came from, instead of being forced to learn how to do things the PowerShell way and write code that's optimized for PowerShell and PowerShell users, instead of leaving it the old way. So it does take a so .NET developers have some advantages in learning PowerShell since it is a .NET language, and that much of the syntax comes straight from C#, but they're at a disadvantage in learning to not do things the hard way. Cool. We got a few book fans out there. All right. Michael's leaving us for tonight. Good luck on your drive. And some of us will see you next month. And some of us will see you shortly on the Slack. It's Christmas, but we're geeks, so we got nothing better to do. We're probably hanging out on the Slack anyway. With my last 3 minutes, wanted to tell everybody who hasn't heard about it, about adventofcode.com. Advent, like the holidays, of code.com. Awesome scripting games or coding games site where for every day for the first 25 days of December, there's 2 puzzles per day are released. And in order to get to the second puzzle, you have to enter in the correct result from the first puzzle. And it's just really cool, and it's Christmas themed. So there's some big story about some convoluted reason why this puzzle has to do with these elves up at the North Pole, even though it doesn't really, but we pretend, and it's fun. And and starts off super simple, and then grows in complexity and in interestingness, and it's a challenge to figure out how to think and approach problems. And then the second half of the puzzle are often really throw a monkey wrench in things and make it fun. Sometimes it's a completely different thing built on what you did in the morning. Sometimes it just takes it to a whole different level. There's one where you got to figure out how these plants are going to grow over 20 generations in the morning. And then you figure out how to do that and do it in a reasonable amount of time, and you plug in the result and says, cool, now what's going to happen in 50 billion generations? And you have to completely rethink everything you did, because what you do for 20 loops is very different from what you do for 50 billion loops. And sometimes that's when you step back and say, okay, how do we do this without looping? That's not practical. Maybe there's a different solution. How else can I find out how this is going to work out? So that's always fun. Anything in the, should move this closer to the chat just in case. Coming up on 6:29. So that was adventofcode.com, and I highly recommend it. Oh, I could type it in here. That would work and everything. Adventofcode.com. So that's a fun site. And so I've got about half of them done so far. And that's what I will mostly be doing with my Christmas holidays. Anytime my wife is not yelling at me to spend more time with the family, I'm going to be playing with that. So it's 6:30. I'm going to go ahead and get started. Again, for those of you coming late, my name is Tim Curwick. I am a PowerShell MVP. I have been doing PowerShell since before it was called PowerShell. I've got 30 years background as an infrastructure engineer, systems admin, all the way on back, anything and everything Microsoft Stack server side. I've played with it. Senior systems engineer for 20 years almost. Been focused on automation for 5 or 6 years. Automation consultant, last several. Currently working at RBA Consulting in the Twin Cities, doing big PowerShell-based automation projects. Currently working at a large enterprise in the area, automating admin tasks on Power BI, which is quite a challenge. Yet another Microsoft API to learn with all of its quirks. They love writing quirky little APIs. This one's fast, though. I like that. That helps a lot when you're trying to deal with some of their other APIs with Azure and Exchange and everything else. And a lot of the hard work is figuring out how to deal with the fact that it's ridiculously slow. Don't have to do it with Power BI. It just has other quirks. But it's fun. Tim mentioned earlier, one of the authors of the PowerShell conference book, frequent speaker, mostly at the Minnesota PowerShell user group. Also speak at MMS and sometimes other user groups like this one. Got a blog, madwithpowershell.com. I haven't posted much this year. I've got to get on it. I've got a lot of posts that are written but not edited and posted. But there's lots of good stuff there. And I tend to write about fun stuff and write in detail, not just little blurbs. Do this. Here's how you do something ridiculous at great length and very verbosely. So let's kick off our topic for tonight. Somewhere here, figure out the UI again. Let's share the entire screen simply because that's easier. If you're having, since I don't have a lot of feedback here, if you're having trouble hearing me or seeing anything, let me know. When my screen pops up, let me know if, well, A, confirm you can see it, and B, let me know if the size is adequate. I don't know how good the hangout is at letting you see this on whatever device you're watching on and how well you can see my code, because that's what I'm most going to be doing tonight, is talking through a lot of code. But I also had some slides here somewhere. Yeah, let's do some slides. There's me. Oh, and I'm on Twitter at MadWPowerShell, because Mad with PowerShell was too long. Mostly I just tweet that I've got a new blog article or I'm speaking somewhere, though. But you can follow me there. Send me an email anytime, madwithpowershell@gmail.com or at tim.curwick@rbaconsulting.com. If you have any PowerShell questions, happy to respond. And don't feel like you're overwhelming me with stuff. If I can't get to you, I just won't answer you. And nobody ever sends me emails. They go to all those other sources instead. But if you want to, send me an email. Or if you got any questions about being an MVP or about the group or moving to the Twin Cities and working for RBA Consulting, let me know. That's from a previous iteration of this. PowerShell error handling and logging. We do PowerShell so that the computer can do work so that we don't have to. We want it to run in the middle of the night all by itself so that we don't have to do anything in the middle of the night. And so it needs to be able to handle whatever might come up. It needs error handling. And once we've got things out there like that, we need to be able to know what they did, make sure they were doing what they were supposed to be doing. So we need it to do logging so we can see what it did. If things go wrong, we need to be able to support what happened. We need to be able to get detailed information about what it was trying to do and what went wrong when it went wrong. We need that. We need that logging. I am fond of saying any script that requires human interaction is a broken script. It needs to be able to live by itself and work by itself and do what it does all by itself. And it needs to be able to create the artifacts so that we can come back to it and get what we need. And that might think there are some exceptions. If you are writing tools to use at the command line or in your scripts, or you're taking those modules and giving them to other people so that junior admins can go do these tasks so that you don't have to, you still need a level of intelligence in there. It needs to be able to handle stuff that comes up and to handle anything that this end user might need. It needs to be able to just not throw red up on the screen. It needs to be able to know when to not throw red on the screen. It needs to know how to write useful information to the screen so that end user can figure out how to handle what's going on without having to come back to you for support. Plus, you need to know what that user is doing. So if you give them a tool to go out and create stuff, you need to know what they were creating and when and why and how. So it needs to do logging. So for almost any script, adding logging and error handling is incredibly helpful. So how do we do that? Well, the first way to handle errors, wrong slide. So the error handling and logging are very tightly intertwined. They are inextricable. Some of the most basic error handling and parts of the more advanced error handling is just logging that an error occurred, putting the information about the errors in a location and in a format that we can get to it and usefully respond to it if we need to, or it's ignoring errors but logging them so that we can know that they did occur. Very often we need to do logging so that we know what types of errors we need to handle. Sometimes there's lots of errors we can't anticipate in advance. We got to wait until real life to find out about them. Now, I commonly write scripts for companies with over 100,000 users, and no matter how hard we test them in advance, as soon as we put them in production, those 100,000 users, that kind of load is going to find all sorts of errors that we didn't think about in advance. It is an iterative process where we're kind of going back and forth between, creating the logging, finding out what the errors are, doing the error handling. Now that we handle some sorts of errors, sometimes we need a different type of logging would be more useful for what's really happening, for the errors that we're not handling. And then as you go through your development and testing and then on to prod, you got to build time in for going back and revising your error handling for the errors that show up after you actually get out there into prod. So it is an iterative process as we figure this all out. So how do we handle the errors? Well, best way to handle errors is don't make mistakes. Now, that sounds facetious, and of course it is to a certain extent, but there's actually something to that. That is actually a technique that you do need to use. So let's go take a look at the demo. All the rest of this is demo. Let's look at some code. And this code is posted online. I will put out a link to where you can find the code at the Minnesota user groups GitHub. And I'll talk to Mike about if you guys have a repository where I can put it for you guys to get to. So, for example, if we have I have a function that gets a string, and I'm going to use that string, but if it mentions server 1, I want to change that to server 2 any place in my script. I just use a simple replace method. But if I run that and it turns out that string is null because get value didn't return anything, then it throws an error. Which brings us to another bonus fact. Error handling isn't just about how the computer handles errors, it's also about how you handle errors. And you're a human being, which means your brain is broken. Humans are weird, our brains are all screwed up. If you hear an alarm and an announcement, you're going to do one of two things. You're either going to ignore it, or you're going to jump up and react to that alarm, run out of the building, grab a fire extinguisher, beat someone over the head with it. You're going to react somehow. What you're not going to do is actually listen to the message. Because when alarm reaction kicks in, we just react. Same thing happens when red screen throws up on the screen. Red text jumps up on the screen. We do one of two things. We either ignore it, or we immediately try to go find the error and fix it. What caused this problem? What we don't do is read it. And then if you think this applies to you, but I guarantee it applies to all of you, none of you read the red messages as often as you think you do. And by making the simple change of changing the color of your red text on the screen to green, you'll magically become better at reading text, reading error messages. Can't tell you the number of times in forums and Slack and everywhere else where I've seen people post, I was trying to do this and I got this error message. What happened and what do I do about it? And when you look at the error message right there in plain text, it says exactly what happened and what to do about it. Lots of times they don't, but sometimes they do. Make it green, read your error messages. Helps a lot. So anyway, string is null and replace is a string function, not a null function method. So when we try to run it, it throws an error. Now I don't care that nothing happened. I don't care that there was an error. If string is empty or null, I just want it to stay that way. So I can just very easily avoid this error by wrapping string in this. I just cast it as a string, throw that in parentheses so that I then have the string object, and then do my dot replace, and then it works perfectly fine. And what I get out of it is an empty string. It did change a null value to an empty string. 99% of the time, I don't care about that. If it does, I'll do something slightly different. And it works just fine. And this is a very safe statement. I don't have to worry about this throwing an error. This will never throw an error. Everything in PowerShell is a .NET object. All .NET objects are required to have a method called toString for converting them to strings, and that's what PowerShell uses when you cast something as string. So absolutely anything can be cast as string. Not everything converts to string in a useful way, but the relevant fact here is that they do all convert to string without an error. So just by that simple change, I don't have an error there I have to handle. Another example. Let's say I've got a set of data about my users, and I'm going to have to go do something in Active Directory with these users. The problem is the data I have doesn't have the only consistently accurate piece of information I've got for my users in this set of data is their email address. And so in order to very quickly and easily convert that email address to a distinguished name, I'm going to reach out to Active Directory and just get all the users, including their mail, and I'm going to convert that into a hash table. Hash table is a way to extremely quickly pick out a particular object based on a property, much, much faster than any other method in PowerShell. So I just create a hash table, I get everything, I pipe it to for each, and then for each, I add a hash table item with the mail as the key and the distinguished name as the value, and that will give me a real quick lookup for distinguished names. Problem is when I run this, I get an error, and I get an error because I'm getting everything from Active Directory, and not all users in Active Directory have mail populated. Even if you do populate it for all that users, you're going to have different system type things that don't have mail, and when that happens, this is null. And this particular syntax chokes on that being null. So all we do is we just take that one line and we wrap it in an if statement. And so for each object, we check to see if the mail property is populated. And if it is, then we add it to our table. If it's not, we don't care about it because we only want those things that have a mail in it anyway. So we just ignore all those. And an if statement is incredibly fast, excuse me, relatively speaking. The using an if statement like this and running that conditional over and over again for 100,000 users is actually faster than using where object in order to filter down to this level. Where object being another way you could do this, but where object has its own issues and it's slow, and this is really fast. So now we run that, and we've got our hash table that we can use for lookup. So then anywhere we've got an email address, we can just use the hash table to instantly tell us what the distinguished name is for that particular user. Did I have another one of those? Another thing to do is just to handle problems before they become errors. So I mean, this is error handling or unexpected behavior handling, but we're avoiding an actual error. We're not getting the red code we have, the red text we have to handle. So in this example, we're looping through a bunch of employee IDs. There's an in-house HR API we can query, and we've got a wrapper for to get information about that user, and then we've got a function we can run to do stuff to each user. But we run that, and we get an error because it turns out that one of the employee IDs in our list isn't coming back from the HR API, and so it breaks the script because do stuff requires a user. So all we do there is we just throw in a little if else. So for each employee ID, first thing we're going to do is we're going to set user to null. And so that way, even if something weird happens on the next line and user doesn't get set, and for some reason stays on what it was, we don't still have the user from the previous loop. That would be a problem. So first we're going to set it to null. Now you'll see a lot of people, especially people coming from a development background, who will take all of the clearing out of variables and put them at the end of the loop. But to me, it makes a lot more sense to put it up here. It's in context. I know exactly what it is and why I'm clearing out and where it is. Right here is where I care, and I'm working on this, and I'm looking at this, and I'm seeing that it is null. And this is a big, huge loop or big function. I don't have to be looking somewhere else and try to figure out based on the logic whether or not this is going to be null by the time I need it to be null. I know it's null because I just set it that way. So we run the query, and then we just check to see if it is a populated object. If it is, then we can go ahead and do stuff. And if it isn't, then we just write to the log. We don't want to kill the script because we still have a lot of other users to work with. We just want to write to our log that we could not find this particular employee ID. And so now if we run this, we get an error. but we get a completely different error. This time we get an error because we haven't defined write log yet. So let's go do that. First off, to do our logging, up at the top of the script, we're going to have something similar to this in every single script. We're going to define where we're putting our logs. This might be up in a variable section up at the top, along with everything else. Anything that I'm quote unquote hard coding in my scripts, I'm putting up at the top of the script. So they're all together, they're easy to find, they're easy to edit, easy to see what the dependencies are. Those are all together. I might take something like this and make it a parameter of the script and just make this a default value for the parameter. And so then if I ever do take this and make it a scheduled task or something else, then it's already got the parameters there. I don't have to do extra work to make that happen. Things that likely might be useful parameters in the future, I just make them that right from the start, and it's real quick and easy. And then I've got a file base, and I'm going to do this in every script, where I've got a unique short name for what I'm doing here. And then this is going to be used as a base all over the place. It's going to be in the name of my logs. It's going to be almost definitely be in the name of the script. It's going to be in the subject of emails that get sent to end users or to my support team. It's going to be in log files. It's going to be in other output files. It's going to be in config files. It's going to be in the name of task and task scheduler or automations in Azure Automation or Orchestrator or wherever. Make it real easy to find the related things. Then I'm going to build a date string that I'm going to stick in the name, and definitely have year, month, and day. Some cases, hour, minutes, and sometimes even seconds. All of them as big as possible, so that they and in this order, so that they automatically sort in date time order. Hours and minutes, not always going to have that, but the places that you're going to have them will likely be the exact opposite of what you might think. Now, if I've got a script that starts that I'm running every 5 minutes to check for work, I'm almost definitely going to not have hours and minutes on there, because I don't want a new log every 5 minutes. It is a royal pain to have to go through, search through all those logs to try to find relevant information when something went wrong. So we're just going to start a new script every day and then just write to new log every day and write to that same log every day. If I've got a script that's just going to run once a day, though, I'm actually going to put the hours and minutes in. Couple reasons. First off, while in production, under normal circumstances, it might just run once a day. When I'm developing, testing, debugging, I'm going to be running it multiple times. And in those cases, it's usually very useful to have a new log each time, rather than having to pull up the same mass log, scroll all the way to the bottom, and try to figure out where your latest run starts. This way, those are all discrete. Also, just by looking at the logs in File Explorer, you can see when your script ran. And so if it was running at an odd time, you'll immediately see it without even having to read the log. The other thing is that right here, the start time of your script will be embedded in the name of the script, and the last write time of the script is when the script ended. So just by looking at the log files in Explorer, you see the start and stop times of all your automations. And then we take them, string them all together, and that's going to be our log file for this script. And then if I'm doing multiple types of logs, doing different kinds of logging, I'll just stick in another dot and a little one-word description of what kind it is. Or if I'm going to do a different kind of output, just minor variations there. And in what order you put the things between the dots, so it depends on what's going to make sense for how you would like to be able to sort these things. And don't do it in such a way that it sorts by dates, because you can use the date column for that. But so you sort on something else and then date within that thing. So then we can do our logging. You're going to end up with probably a couple variations of write log that you use a lot. I've got two. I'm going to show you first some simplified versions of those two to start with, and then later in the talk I will show you some more advanced versions of those. And these are all included in the code that's online. This whole script here is all online. And by having these standard ones that you use all the time, it makes it real nice and easy. You just have this function at the top of every script, and then you just use write log throughout it, and then it makes it real easy to copy code from script to script, and it makes it real easy to copy the function from script to script. And if for a particular script or a new point in time at your organization, you want to start doing logging differently, maybe you want to start writing the SQL instead of text files or whatever, you just tweak this function, copy the function in your scripts, and you're done. Or you have your function in a module that everything calls, but I tend to write monolithic things where I just stick the functions in everywhere. I used to modify these functions a lot, and every time I'd reuse them, I would add more bells and whistles and want to do more and more fancy things with them, do all kinds of cool stuff with them, or tweak them for different circumstances. But I quit doing that because I realized that I had this dependency on which version of write log was being used in particular scripts, and I didn't want that. That we want code reusability. We want things to be able to easily move around all over the place and be able to do anything, anywhere, any way we want. And most of the bells and whistles weren't really that necessary. They were easy to work around. So I pulled most of them out, and now I just have two functions that I pretty much use for everything with some minor variations. So for the first one, we create our function. We put commandlet binding up the top because we put commandlet binding at the top of almost every single function and script we write. We do that sometimes because it magically makes advanced functionality work without us having to do any extra work other than putting in that word. And I think I have an example of that later in the talk. But even if it's not doing that, commandlet binding can make a function work better and a little faster, because the way PowerShell handles variables within a function that has commandlet binding is different from how it normally does, and it's actually better and faster from the way PowerShell normally does. They haven't gotten around to porting that functionality back and making regular PowerShell work that way. In this version, I'm just taking a single parameter, just the text I want to log. I also kind of need the log file, but I'm going against best practice in this case, and not actually making that a parameter, because it's never going to change within the script. The whole script is logging to the same place. And I'm already taking away the readability of the script by throwing all these write logs in the script and cluttering it up with this extra stuff. And so the less extra stuff I've got in my write log command, the less it interferes with the readability of the script. So I don't want to have dash log file, $ log file every single time. So it's going to be the same everywhere anyway. So I'm just going to ignore it and assume that it's there. So then I take the text, I prepend the date and time to it. I output it to my log file, pending it, UTF-8 because we live in a global world. And then I'm also going to use write verbose to write it to the screen. Most of the scripts are going to run unattended, but once in a while you're sitting there watching, especially if you're testing and or debugging or coding, and so you do want to have that there on the screen when you're looking at it. We're doing write verbose because we don't want to write to the output stream and clutter and pollute the output stream. The script or function might have actual output, and we don't want these log entries interfering with that. So we're going to put that in a verbose stream, so that just gets ignored by anything that doesn't care about verbose. And verbose also makes it a pretty color without resorting to the evil of write host. Don't use write host. And we use the verbose switch on write verbose in order to force it to write to the screen, no matter what the verbose preference is set to. So we define our function. And now when we want to log about employee, now it works. It's writing to the log now, and it is logging to the screen. that we can see what's going in the log. Here's a nice little trick I picked up a while back to distinguish between data in the log that's coming from a variable and data that is hard-coded. I put the variable in square brackets. Does two things. One, it makes the variable data more apparent and easier to see. If I'm working with a log that I work with frequently, I'm only going to be looking at that data. I don't care about the other stuff. And also, it makes it pop out when there's data missing. If the employee ID was missing without the square brackets, it would just say emp ID not found, and it wouldn't give that extra visual hint that that employee ID is an empty thing when we are expecting something there. Nobody's saying questions on the chat, so I will assume that there are people still awake and watching, and we'll go on. The other small variant is just to have the function write to a CSV file instead of to a text file. The advantage of this is you can open it in Excel and then you can do sorting. With a lot of logs, we don't care about that, but sometimes we do. Sometimes you're logging, depending on what types of things you're logging, sometimes you're logging actions. You need to be able to go in and sort by user, computer, things like this. Sometimes you have scripts that run in multiple places. That might have something that might run in any of a dozen different computers, and you want to be able to pull all that data together and look at it together, but having a column for server name makes it so that you can sort by that. So that if you're having, you have an automation that runs on 6 different automation servers randomly, and it's blowing up 1 out of 6 times, well, one of the server has problems. Pull in all the logs, sort it, you know which one. You might have be doing some sort of multi-threading where you have multiple processes running at the same time on the same machine, and so then we can have those all write to the same log, and we can add a column for process ID for the PID, and so then we can look at the logs and either have it sorted by date time and see how things were happening in real time, or we can sort by PID and see how each process was doing individually. So first thing we do is create a PS custom object, because that's what we need for working with export to CSV. Put in the date, the server, and the text, and then we export it to CSV. UTF-8, no type information, append, and away it goes. One thing to keep in mind, if you might have multiple scripts or processes or whatever writing to the same file, you have to be very aware that all of your PS objects that you're exporting have to be exactly the same. They have same properties. Otherwise, the export won't work right, and you'll lose information. You'll have missing columns. Almost every issue. Just a gotcha to be aware of. And then we write it to the screen. This weird little thing here digs deep into a hidden thing in every object in PowerShell to pull out the property values and join them all together in the order that they are up here. And that way I can do this in just a single line. And if I come back later and I add 6 more columns that I want, this line will automatically take care of that and automatically just dump them all to the screen. So I'm not going to run that because we're not going to use that one, because if we test that now, it's going to try to write to the same log file as we already have in there, which already has different stuff in there, and it's going to choke because it's not the same as what we have here. But if you try this in real life, it works. So then here is a sample of going through and doing a bunch of logging. Another part of the human aspect of error handling. It's not just what the script does, but what people have to do with the script. Sometimes error handling is going and finding out what went wrong with the script, or how you have to change the script to handle new circumstances, new business requirements, new APIs, whatever. How do you avoid file lock on shared CSV? You use version 2 of my module, mad multi-threading from the PowerShell gallery, which I haven't posted yet. There is Yeah. That is another. Oh, but does bring up another another gotcha thing to be aware of with the CSVs. When the downside to using a CSV, a couple downsides. One, most of the time the machines that your automations are running on are servers which do not have Excel on them. So then you open the CSVs in Notepad, and it's very difficult to read them. And in those cases, just a regular log can be better. But if you do have access to that log folder from your machine, then from your desktop, then you can just easily open the log files from there. But the thing to be aware of is when you open a file in Notepad, it does not lock the file. And so you can be always opening logs in Notepad, and scripts can continue writing to them. But if you open a CSV file in Excel, Excel locks the file. And now your script can't keep writing to it. So if you've got a script that's in process and you need to look at the log, don't use Excel to look at it. Copy it, then open in Excel. And if you have multiple things that need to write to the same file, then there's some. Then what I've had to do, the only times I've really had to do that is when I was doing multi-threading, which is advanced stuff for PowerShell, where I had multiple threads running the same time on the same machine. And then what I'd have is I have an additional thread that does all of the logging. And so all of the other threads write their logs to a queue, specifically a blocking collection type object for those .NET people out there. And then that other thread picks them up and writes them to the log so that there's no file contention. Yes. So people need to be a part of the process of going in here and messing with your scripts. So don't write scripts the way the 99% of the scripts are out there. Don't write them the way the .NET people write their scripts. Write them like this. Lots of internal comments, lots of white space, lots of information about what's going on. And redundancy is okay. It's good. It's desirable. So we've got a comment, query HR API. We're writing to the log, query HR API. We're writing the command, query HR API. And then we're writing to the log what happened after we queried HR API. And that's okay. Another bit of advice for interacting with stuff: pick a code editor and stick with it. That's why I'm one of the last people still using ISE. I'll switch over to VS Code eventually, but for now I'm still on ISE. Pick a code editor and stick with it, and pick a color scheme and stick with it, because your brain adapts and gets really, really good at quickly and easily understanding the colors that you work with, which is why I haven't switched to Visual Studio Code yet, because you can't perfectly replicate the color scheme from ISE in VS Code, because it uses different sets of tokens and it identifies different things differently, so it can't have the exact same colors. And your brain gets really good at it. So once you're good at looking at these, if you're looking at these particular colors, you can really easily just go through and read all the green, read all the comments. And by doing that in my scripts that are very heavily internally documented, it's really easy to go through and see what it does and find the section that you need. Or you can just go through and look at the commands, or just go through and look at the text. So it's okay and necessary to have that redundancy, because if you're only looking at one set of stuff, you need all the information in that set of stuff. So anyway, first we're going to, right at the beginning, we're going to log that we're starting to do this. And we're going to do pretty heavy logging in this one. You don't always do this heavy logging, but there's very, very often no reason not to, and you'll be surprised how often it turns out you're happy you did. We're going to loop through all of our employee IDs. At the beginning of each loop, we're going to write which one we're working on. I'm going to use this syntax a lot, where we're just putting in variable name, variable value. And if I'm doing very heavy logging, every single time I touch a variable, I'm going to log what the change was. Then we log that we're going to do something, and then we do it, and then we log the results. And so here, They were getting the name of the user that we got back. Sometimes for a complex object, I'm going to log a lot of different properties. In this case, I don't care about the details. I just want to see the name of that object that came back for this particular ID. So I can see whether or not something came back and what the value is. Now, you can have multiple lines like this for multiple properties, and most of the time that's perfectly fine, and it's a good way. It's like, format list, good way to go in and see what the properties are. Be aware, though, that sometimes it turns out that you need to go back and look at a bigger chunk of information, and you might have to better understand what was happening when across tens of thousands of users across multiple runs of the script with all these logs. And if you have the user broken out into multiple properties in this format like that, it can be a real pain to go through and parse and figure out what was happening where. So if you might need to be able to extract data out of the log, then it's time to think about formatting it differently, maybe having a custom log just for that information, but making it a CSV with the particular entries, in particular columns, so that you can more easily get that information back. Sometimes some of your logging you're doing so that you can undo what you did. So you might have one log where you have this type of logging, but then you have another log where you just have the columns where you did what exactly you did for each user. So then if something happens, then you can use that log as the input for another script that just goes through and undoes everything that you just did. So we check if we have a user. If we have one, we log we're doing stuff to it. Then we do stuff to it. Then we log that we did it. And then we, if we didn't have a user, then we logged that we couldn't find the user. And then at the end, we log that we finished processing our users. This one might seem silly, but I learned the hard way to put that in. Say, for example, this thing processes new users every day, which at a big organization, might average around 200 a day. Then one morning you get the email from the automation saying that it successfully processed 3 users. You're like, well, that doesn't seem right. You go look at the logs, figure out what happens, and the log just shows it did 3, and then the log just stops. Why did the log stop? Did something happen to the script, or did it? Or did it really think there were only 3 users to do that day? And so just having that last line in there to let you know that as far as the script's concerned, that's all it needed to do. It successfully finished, went on its way. Can be very helpful. So if we just grab all that and run it, and yep, start processing. Play 113, querying. Got Joe, did stuff, successfully did stuff. 182 queried, found nothing, then processing. Nice and easy. And especially once you get once you do that a couple times, it's real easy to just plug in all these right logs. And you can do it at the same time you go through and do the internal comments, and you don't necessarily have to do it as you're going along. Just when you're reasonably done with your script, then you go through and then plug all those things in. Sometimes helps you rethink things and understand how things are going to have to articulate it that way, and you just plug those in real quick. And it makes life so much easier when you have to come back in a week or a month or 2 years and try to figure out what the hell you did. Or worse, when you're off doing better things and someone else has to do it and you don't want them to have to come wake you up. You're supposed to be able to sleep through the night now. You're the boss. So let's go back over to error handling. Unless anybody no more questions. So either everybody's asleep or we're good to go. Try catch finally is the primary tool for error handling. And all it does is in normal operation, everything in the try block just runs normally. If there are no errors, the catch is totally completely skipped. If there is a finally block, then everything in the finally block runs. If it's going through, I got a comment. I saw there was an empty value in the log. Was there? Yes, it correctly caught that there was an empty value in the log. All All right, if we're running the try block and there's an error while we're in there, it skips the whole rest of the try block and jumps down and runs the catch block instead. And then when it's done with the catch block, then it goes and runs the finally block. You don't use the finally block very often, but it can be useful sometimes. It is optional. Catch block can also be optional. You have to have either a catch or a finally or both. Lots of different reasons to use try catch. Sometimes it's a nice, it's the ultimately, silently continue. Silently continue doesn't always, error action silently continue doesn't always catch everything. Sometimes setting that basically sets the error action preference for what it's going to be internally to the command. But sometimes the error happens before it gets to the command. Sometimes the error is when it's trying to do stuff with parameters. And sometimes the command doesn't care what you set that to, and it finds ways to throw errors anyway. This is the ultimate silently continue. If we do this, we will never ever get an error. Try to do this. If it doesn't work, do nothing. Skip down here and do nothing. I don't care to know what happened or to handle it or anything else. We'll try it. If it works, it works. If it doesn't, it doesn't. As an example, so if I've got a path to something that doesn't exist and I try to do get item, I get an error. It doesn't exist. But if I throw error action silently continue on it, then I don't get an error. It's nice, polite that way. Mike, I'm not sure what you mean. Yes, we will come to that, and I will be sure to highlight it for C# people. Sorry. Yeah. Error action silently continue catches that one. But if our path is blank and we run error action silently continue, we still get an error because the error happened when it was trying to send path into get item. It never got into get item, so silently continue never took effect. So we still got the error. So if we take the whole thing and we run it, wrap it in try catch, now we get the now we have successfully suppressed the error, and file becomes null in this case. If we put the file equals on the inside, then file would be unchanged. By putting it on the outside and doing the try catch and nothing happens, file becomes null. Another example. If I create a run space pool and then I open it, this is a thing for multi-threading. The .NET people know what this is. Most other people don't. Doesn't matter what it is. Just the fact that we've got this function, we opened it, and then later in our script, we want to make sure that this is open, so we try to open it, and it throws an error because it gets all kinds of cranky if you try to open it again after it's already been opened. So if instead, we just wrap it in a try catch, we could do the work to figure out how to only run this when it's in the right condition, or we can just wrap in a try catch, and then if it can be opened, it's opened. If it didn't, it didn't. That's fine. I'm perfectly fine with it. All right, so let's do a simple try catch for actually doing something. So in this one, we're going to, and I'm putting lots of logging in these so that we can see what's happening where and what's happening what isn't. So we're going to loop through twice, and we're going to write to the log what we're doing, and then we're going to try to divide by whatever our I is, and we're going to log our results, and then we're going to say we were successful. If at any point we get an error, it's going to jump down here to the catch block instead. So if we run that, so we started I equals 0, try to divide it, and it jumped down here and did error. It skipped this part. As soon as you get an error, it skips the whole rest of the try block. So we got the error, went through again. Now I is 1, our result is 1, and it was success. I is 2, result is 0.5, and we got success. And that's how try-catch blocks work. The simple ones. Does try-catch not have the overhead PowerShell? It doesn't C#. It has some, but in sorry, I should but it PowerShell, where we're not as concerned with overhead. It's extremely rare that we're trying to shave nanoseconds off of a function in PowerShell, and so if something takes a few milliseconds longer, we don't care. Does a little bit of stuff in memory, we don't care. There are extreme circumstances where that kicks into play, but that is extremely rare. You got to be doing crazy stuff, but well, I wouldn't say crazy stuff, but there is if you care about the amount of overhead the try-catch writes, you're probably not going to be doing it in PowerShell anyway, or you just caring about stuff you shouldn't. All right, so while we're here, let's start diving into looking at error records. Because like everything, they are big, complex things. Every time there is an error in PowerShell, it gets added to the built-in variable error. And it sticks it at the top or at the bottom, depending on your look at it. So the most recent one is always error 0. And when we look at that, we get the same stuff that popped up in the error message, which isn't necessarily very helpful and hard to read, and some of it's helpful and some of it isn't, and everything else. Well, the first thing I'm going to do is I'm going to take and assign it to E. And I highly recommend anytime you're digging around into errors like this, that you do assign it to a variable, because sooner or later, when you're trying to dig into it and look at it, you'll throw another error because you try to run a method on the wrong place or something like that, at which point the error you want to look at is no longer error 0, it's now error 1, and then you accidentally do it again, now it's error 2, and you're chasing it down, it's pain. So we're going to assign it to a variable so that we just have it in E. Now, the error isn't just this stuff here. This is just what somebody early on in PowerShell's history thought it would be most useful for us to see, so they made it so this is what automatically displays anytime we send an error record to the screen. Of course, in PowerShell, you want to see everything. The way you do it is send it to format list. And when you do that, we get the same thing because they thought they were being really, really helpful and make it do this every time, make it harder to get stuff out. So, of course, we can just add the asterisk. That'll give us everything. No, they got all kinds of ridiculous with this one. It's real annoying. Now, normally I'll never, ever use abbreviations for commandlets. We don't use aliases in our scripts, but you're never going to be doing this kind of looking in your script. You're not going to use format list in a script. If you're at the command line, use aliases all day long. That's fine. With tab complete, it's almost never necessary. But for format list, you got to type it all the way out, format-L to get to the tab complete. So go ahead and use FL. If we do asterisk and dash force at the end, now we actually get to see the entire object, or at least get to see what the properties are and see the default values of those. Most of these are themselves complex objects that have more in them than just what displays on the screen here. And some of these can be very helpful. Some of them aren't. Some of them are the kinds of things that only .NET developers would care about, and you know, sorry. A lot of it is stuff that happens at a layer that we will never know about or care about in our scripts. But the most common one that you're going to want to look at more is the exception. The exception is actually, in some ways of thinking about it, is actually the error. This is what .NET throws. When .NET has a problem, it creates an exception. PowerShell takes that exception and it wraps it in an error record. So what we're looking at here is the error record. Within that is the exception. When we look at the exception, we get just the bare message, because again, they thought they were being helpful. So again, we have to pipe it to format list asterisk dash force, and now we get to see the entire error record. Again, a lot of stuff that's not necessarily helpful, some stuff that's sometimes helpful, some stuff that's otherwise helpful. So here is the actual error message. So if you ever need to pull that out within a script or your error handling, that's where you get it. It's in the error record in .exception.message. The H result down here, that is an error code. So you can sometimes Google that and get useful information. Not always, but sometimes. It looks weird here and it's negative. The first thing you would try to do if you tried to Google that and that didn't work, if you take that and convert it to hex, it would suddenly look very familiar. It's going to be one of those 0x8000 numbers that we've all seen as error codes for decades. And so sometimes if you Google on the hex version of it, you're more likely to find something. Not frequently, but once in a while. So I talk about it in here. Let's come back to that. One of the most useful bits of information about an exception is kind of in a secret location, because it's not a property. It's not something you can look at here. It's in the type of exception that it is. And we see that by running the get type method on the exception. And then we do .full name, because we always do that when we do get type. So because this is the most useful thing to get. So if we run that, we can see that this was a system.management.automation.runtime exception, which isn't necessarily that useful in this case, but often it is. And I'll show you why it isn't useful in this case, but we can still dig deeper. Because as errors are bubbling up through the layers in .NET, very often the different layers will wrap an error from a lower error in another error, or specifically an exception within an exception as they send it up. And so in a lot of cases inside the exception, there is an inner exception. And the inner exception often gives you more useful information than the outer exception. Not always, but sometimes. And so if we do e.exception.inner exception, format list star force, we can see the inner exception. And so here we can see again, we have the message in there. In this case, it's the same. Sometimes they're different. So sometimes at a higher level, you'll have a generic error, and in the inner exception, you'll have a more useful error message. Sometimes the inner exception has an inner exception, but that's very rare. But they can keep nesting if they want to. And it can also be more useful to look at the type of the inner exception than the outer exception. So we take the inner exception, take it to get type, and do full name. Here we see this is a system.divide-by-0 exception, which is a much more useful thing than just runtime exception, which practically everything is. So let's look at a specific example. Let's run invoke rest method on a thing that doesn't exist. And let's take that error and stick it in E2 so that we can more easily look at it. And let's look at the full thing here. And so here we see we do have an exception. We also have a target object in here, which is most of the time not a useful thing, but in the case of web exceptions coming from REST method, it's an extremely a useful thing. So whoops, put that back. Let's take a look at that target object. So inside the target object is the .NET object that invoke REST method used to make this web call, and it has within it all of the detailed information about how it tried to connect and what its settings were and what the headers were, exactly what it talked to and what it did and everything else. And so if you're having a lot of trouble trying to figure out how to talk to an API, for example, you can go in here and look at these settings, and sometimes something will jump out at you as wrong, where you can be, researching the API and seeing what requirements they have for how you connect to it, and you can look at the settings here and see what the settings were, and then maybe if one of them isn't set right, then you can start looking at the the different parameters for invoke REST method and figure out how to override the default settings and make it so it actually works. Or you might find that there's something that you can't do with invoke REST method, and you have to fall back using directly using .NET objects in order to do your communication. So sometimes there can be very useful information in here. Not always, but sometimes. Let's take a look at our exception. And see that on this one, again, we got all, much of the same stuff. We've got a very generic message here, 404 not found. Let's look at the type of the exception. It is a system.net.web exception. Now, one thing you might not have noticed, or almost definitely didn't notice, is that this exception has different properties than the previous exception we looked at, because it's a different type of object. Every different type of exception is a different type of object, and they can have different properties. And so going in and seeing what different properties they have, some of them have useful information. This one has a response object, which is something that most things don't have. So if we go in and look at the exception.response, we can see it is all of the header stuff that actually came back in response from the web server. So we can see in more detail what's in there. We can see all the headers. Sometimes there's useful information within that. We can look at the status code, which is not found, but I happen to know in this case that it's not just the text not found, that's actually an enum, an enumeration. And so if we convert that to an integer, cast it as an integer, we get the 404. And so we can have build error handling that looks at the status code and responds differently to different types of status codes. So 404 not found might be different from 500 server error or all the different various types of things that might go wrong. This is one way we can differentiate between them and handle different situations differently. We can look at the response headers. When we do that, it gives us the keys of what's in there, and then we can go look at one of them and see what type of server this came from. This particular server, those headers weren't very useful. But for example, if you're talking to SharePoint Online servers, embedded within the headers of every response from the SharePoint Online servers are specific metrics about how long things took on their servers. And that can be extremely useful. If SharePoint Online is acting ridiculously slow for you, and you call Microsoft Help, as with anytime you do any type of support, they're going to point to the huge network in between you and them and your internal network, and dare you to prove that that it isn't within that realm. And so if you can pull this information out of the headers and send it back to them and show them that, no, take a look at this, your own servers are saying you're taking way too long to do this stuff, that can be helpful. So digging around in those things can be helpful. Now, to reference an error within a catch block is very simple. Within a catch block, we've got $_, and you want to do it that way because of the different ways errors can be nested and parts of your script can be nested and functions and modules and everything else. Sometimes error 0 isn't necessarily the one you need to be looking at. Sometimes there were multiple errors and the one that's important to you isn't that one. Whereas $_ always refers to the exact error record that this catch block is catching. So we can do $_.exception.message. So we can just run that, we get the error, and it logs it to the screen. So that's how we refer to an error record within a catch block. Error logging details can be very useful. So we do everything right, we shouldn't get errors we're not expecting. And so if we do get an unexpected error, we want a lot of good information about it in the log. So I will do this a lot. Where if I've got an error, I'm going to first write to the log my own text about what was happening when I tried to do this. And then I'm going to log the error message. I'm going to log the error type, and I'm going to log the inner exceptions message, if any. I'm not going to go for the inner exceptions type because sometimes the inner exception doesn't exist. And then if you try to do get type on something that doesn't exist, then you get an error. So you've got to wrap that in extra code, and it's a pain in the ass, and it's ugly, and it's very rare that it's useful. So for as the standard, I just grab these three things very frequently. I do them so frequently, in fact, that in my actual log scripts, I've got that built in because I don't have to write that out 600 times in my script. That takes up too much space. So here is the more advanced version of my basic write log. So that, and it's not the complete advanced. There is a slightly more advanced version of this that's actually posted that I'll have to send the link out for. Because in my full version, I've got a little bit of error handling in here as well, so that if there's an error writing to the log, that doesn't kill my script. I don't want that to be sufficient reason to not do the important function that the script is supposed to do. I can live without the log if I have to. Other than that, this is the log that I use. This is the function that I use most often. So we've got write log, we've got commandlet binding. We take two parameters, we take the text, and we also take an error record. We assume the log, we prepend the date, we output it to the file, and then we verbose write it to the screen. Then we take a look at the error record that came in, and we check to see if it actually is in the error record. For reasons I don't remember, this is the most efficient and successful way to confirm that this is something we want to work with, rather than just, we don't want to force it, and we don't want to, just do this because it works. We check to see if it's an error record, and if it does, then we just recursively call this function in order to log the exception message type and inner exception message. And just do that anytime that I'm throwing an error record to it. Let's define that. And so with that, and so then within a catch block, I can just do dash error record $_ and it just automatically takes care of all of that. And they were doing this, attempt to divide by 0, runtime exception, inner exception message, attempt to divide by 0. If I'm doing it to CSV, pretty much the same thing, but I'm building a PS custom object, adding the parameters for our column headings for error type, and inner error. And then if I do have an error record, then I populate those, export it to CSV, write it to the screen. So let's start to get fancier with our try catch. A catch block can catch a particular type of exception. So we can we took a look at the type of exception we got when we divided by 0, and this is it. So we can have a catch block that catches that type and only that type. So we define a function called inverse of, and then if we try inverse of 2, the try block gives us 0.5. Then it's successful. We skip the catch block. Inverse of 0, we get an error, goes down to the catch block. It's a divide by 0, so we just print infinity to the screen. If we do the inverse of potato, that does not get caught. Any errors that don't get caught, the error goes to the higher level, which at this level is the script, and so we get the error message on the screen. Also, if you throw an error inside of a catch block, that jumps you out of the catch block and goes up to the next level. But we can nest those. You can have try catch blocks within try catch blocks and get really fancy. And if we have time, we'll look at some of those. All right, let's get fancier with the script. We can have more than one catch block. And they are processed in order. So you put the most specific thing up at the top, and then if that catches it, then that's what happens. If it doesn't catch it, then it checks the next thing and catches that. If we'd put them in the other order, the bottom one would catch everything and we'd never get to the bottom one. So now we do our try, throws an error. If it says divide by 0, we do this. For everything else, we do this. So now if we define the function and run our 3 things, inverse of 2 is 0.5, inverse of 0 is infinity, and inverse of potato is, you're kidding, right? All right, it's times like this I wish I had more immediate feedback in real time. So I'm going to ask, does that make sense? Because we're just going to get more complex from here. I'm going to go on because you can't respond immediately. But if anybody responds in the chat, then I will slow down and go back. All right, let's dig around. All right, let's understand errors a little bit more, and error types a little bit more, and types a little bit more. So let's take our most recent error and stick it in E3. And as we showed, we can do get type and full name, and we can see that that's a system.management.automation.runtime exception. That's the type of object this exception is, and everything in PowerShell is an object. And they're all of different types. And every type of object is based on another type. There's one master type up at the top called system.object, and all other types are descended from that directly or through intermediaries. And so every type is derived from one above it called its base type. And that one has a base type, and that one has a base type all the way up to the top. And we can dig into those. If we do our get type and look at the base type and see its full name, we see that is a system.system exception. And its base type is system.exception, to be confusing. And its base type is system.object. And its base type is nothing. It's the only thing that has nothing as a base type. Everything goes up to system.object. And this is useful because an object isn't just its exact type. It is also all of the base types. It is a runtime exception, and it is a system exception, and it is exception, and it is an object. It's like, my car is a Corolla, and it is a Toyota, and it is a car, and it is a vehicle, passenger vehicle, and it is a vehicle, all the way up to system.object. And so then when we catch things, we can catch it based on the exceptions type or on any of the base types above it. So we can have varying levels of granularity there sometimes. Now, exceptions are defined by the .NET developers that created whatever it is that you're working with, and sometimes they do this more usefully than other times, but sometimes it is very helpful. We can also look at the inner exception, and we can catch things based on the type of the inner exception, not just the regular exception. So if we look at the type of the inner exception, in this case, it's system.divide by 0 exception. Its base type is system.arithmetic exception, and its base type is system.system exception, which takes us back to system.exception, system.object. So altogether, the 4 most useful, unique types of this exception are the runtime exception, system exception, divide by 0 exception, and arithmetic exception. These are all different ways we can think about this object, in which PowerShell will think about this object, and that we can use to catch this type of exception. So we can get a little fancier with our function. Now we're going to do a couple of things. So we got big inverse of, and first we're going to try to divide by n, and then we're going to multiply n by 10. And if that works, it works. We skip all the catch blocks. But if we get divided by 0 exception, we would turn infinity. If we get an arithmetic exception that's not a divide by 0 exception, then we're still going to call it infinity. And anything else, we're going to catch it and still be a smartass about it. So if we run all of these, let's see. So when we did 2, we divided and got 0.5. We multiplied and got 10. When we did 0, we got infinity. We did not do the times 10 because as soon as we got the first error, we jumped out of the catch block and didn't do the second line. When we did the big inverse of the max value of decimal, we got infinity. Or what do we got? Oh, I'm sorry. When we divided it, we got 0 because it rounded to 0, really huge number. Inverse rounds to 0. It threw a different type of error than divided by 0. But we've decided that's also infinity, so we said that's also infinity. And then we tried to do the big inverse of potato, and we were just smartass. So it can sometimes be, can be a very helpful way sometimes to handle different types of things differently. Now, I mentioned we can do nested. And this is just a weird example of how we can, how we can do stuff. So if let's close this all up. So under normal circumstances, if everything runs perfectly, we're going to go into our first try and we're going to do thing 1. And then we're going to go into another try, which goes into another try, and we're going to do thing 2 prep. And then we're going to skip that catch block and we're going to do thing 2A. We're going to write success, and then we're going to skip these catch blocks because we had no errors. But if we were going along and if up in here thing 2 prep failed, we'd go into its catch block, which we decided to ignore because it was something that'd be nice to do, but we don't care. So we're going to put a note in here for anybody who looks at the script. They know we did this on purpose. We're just going to ignore errors in that case. But if we if we get down to thing 2A and it throws an error, that's going to jump down into this catch block, within which we have another try block, which does do thing 2B. And if it's successful, we log that it's successful, and then we skip this try block and skip this catch block. But if it fails, then we go into this catch block, which logs that neither thing 2A nor thing B worked. If, on the other hand, if way up, let's see, if thing 1 threw an error, that would jump us down to the bottom catch block, and we'd just log that thing 1 failed, and we wouldn't bother trying with everything else. So we can use this as a way to structure how we move through code under different circumstances. And of course, you can do this in a million different ways. So we're not going to show every possible possibility, but that's just one complex thing you can do in some circumstances when it makes sense to do so. Sometimes we want to throw an error on purpose. And the way you do that is throw. If we hit throw, we get an error on the screen. So if we try and stick that in a try block, that jumps us directly to the catch block, which sometimes you want to do. Sometimes you want to, that's how you've set up your logic. You want to abandon what you're doing, jump to the catch block. We can get more sophisticated with that. We can throw a particular error message. So, and if we just do that one line of the screen, that's the error message we get on the screen. Superior is too far to drive. And that joke made a lot more sense when I drove all the way up to Superior, Wisconsin to give this talk a few months ago. So if we throw that here, we can see, we get the error message, Superior is too far to drive. And by default, the type of exception is system runtime exception. When we just did the throw, what was the message? The default message was script halted. That's not super useful. So that's why we've switched it to something else. We can also throw a specific exception type. And so if we want to throw a divide by 0 exception, we can just take an empty hash table and cast it as a divide by 0 exception. And so now if we run that, we get the default message attempted to divide by 0, and we got our divide by 0 exception. We can mix and match if we want a custom message to go with our specific exception. We can just have the message as a string and cast it as the exception type. So we successfully get that error message and that type of exception. And sometimes you do this. generally I'm not going to throw a particular type of exception for use internally. Often going to do that for purposes of some end users, so that when if something is failing because I can't find the configuration file, I'll specifically throw a system IO file not found error along with my custom message. Internally, I'm more likely to just use the custom message, or just use throw by itself to get me to the catch block. Now we start to get into some of the weirdness and gotchas and differences between PowerShell and C#. Because if I want to get this item that doesn't exist, but I want to log it, if I can't get it, I throw it in a try catch block and I run it, it didn't catch. I did not get my right log. It threw an error anyway. This happens because PowerShell was written for administrators doing administrative tasks 10 years ago. And for a lot of types of things, we don't care. If you're writing a C# application, you're doing some end user thing, you need to be able to handle anything that comes up. Everything gets handled. Any exception that happens, it's going to do what it needs to do to handle it, or the application is going to blow up. For our scripts, we very, very often don't want that to happen. We're looping through 100,000 users and we get an error on one of them. We don't want to break the script. Just give me some red text and go on and finish the rest of the users. So they came up with the concept of the non-terminating error, where a lot of types of errors by default don't crash the script. That also means that they don't get caught by try catch. Try catch only catches terminating errors. But we can change the behavior of non-terminating errors. And the way we do that is through the built-in variable error action preference. By default, it's set to continue, which means throw red on the screen, but keep going. You can set it to silently continue, to not throw the red on the screen and keep going. Or you can set it to stop in order to break the script or get caught if the error happens. So now, having set the error action preference, now we can run our try catch, and now we do catch the error as expected. And so because I tend to write, most of my scripts tend to be ones that are going to be running unattended and have lots of try catches. Very large majority of my scripts up at the top have error action preference equals stop, so that the try catches will work as expected. Sometimes if it's a script that a user might use on their machine, I will capture the current error action preference up at the top before changing it, so that at the bottom of my script I can change it back again, so that I'm not messing with the settings of that individual. But most of the time I'm running stuff that's going to run unattended, and so PowerShell is going to pop up, run the script, and then go away. So I don't care. I just set it up at the top and let it go. Now, for the rest purposes of the demo, I'm going to turn it back to normal. Just continue. All right. Am I doing this function? Yeah. So in this function, because of the way it's written, we take an employee ID, we invoke our REST method. If we don't get a user, we throw an error. Otherwise, we return the user. So if we run that, and then we get if we run it, we get an error as we expect, because that user doesn't exist. If I do silently continue, it doesn't respect the error action preference, because some function says that's the way I wrote the function. And a lot of functions and commandlets are like that. They don't respect those things. But if you're writing one, you do want it to respect that. What you do is magic. You do this. If you just write commandlet binding up the top of a function, you don't have to do anything else whatsoever, and your function magically now respects error action preference and error action parameter. So I run that. If without it, I get the error, but with error action silently continue, now it works. That's one of the magic of commandlet binding. Just automatically knows what to do with error action preference. You also have to be aware of that. What am I doing here? Yeah, but you also have to be aware of that fact, and also have to be aware that it doesn't work the way you might think it does. Because one might think that if we were to run this with error action silently continue, that it would that it does the function, and if an error comes out of it, that it just then it just suppresses that error. But it doesn't happen that way. It sets the error action preference for the internal part of that code, which can make your code act differently. So especially if you're writing functions for other people to use, you're putting them in functions for other people, be aware of how they're going to how it will respond to changes in error action. So you don't want the end users to flip a flag and then suddenly your function doesn't work the way you thought it did. And so in this example, we're going to do the invoke rest method. If we don't find the user, we're going to throw an error. And so under normal circumstances, if we just run that, it throws the error. If we do it with error action silently continue, we get a result. Because it's nonsensical result. This was just for demo purposes. But normally, a function gets down to throw error, and it jumps out of the function. It kills the function. It doesn't run the rest of the function. But by doing error action silently continue, that went away, and the function kept going, and we got down to the return statement. So be aware, especially if you're doing things like getting fancy with throws and stuff like that, that the behavior you're going to get out of that is going to be different depending on how somebody does error action. All right, let's do more fanciness. We can rethrow errors, so we can do nested try catches to do fancier things. And so I will often have construction like this, where I've got a master try catch. The master catch sends out an email alert, and then with the try, I've got a bunch of individual try catches. And so for each of those, I try to do something, and then I log that particular thing and set the error message that goes with that thing. And then I do a throw as a way to skip all the rest of the main try and jump to the end to go to the catch. And so we import the module. If that fails, we log it and skip to the end. We try to get the users. If that fails, we write an error and skip to the end. Et cetera, et cetera. Anything that we can't possibly do with the script without, we can just rethrow the error. We just take the one that came in, throw it back out again, and jumps us back out to the end. And down at the bottom, I've got my stuff set up, and I throw in the error message that came from up above into the body and send out my email. In real life, I'd wrap that in a try catch too, but I will also do that to catch unhandled errors. I'll have scripts where I've done my best to go through and come up with every possible scenario, and I've got to try catch to grab everything. Do what it needs to do, and log what it needs to log, send out alerts as it needs to alert, and it handles everything. But I'm not perfect, and weird things happen. So something might get through that I didn't catch. So if something gets through that I didn't catch, I want to know about it. Fortunately, we can know about it. If the only way, theoretically, if I did it right, the only way we get to the catch block was if we threw something and got here on purpose. So I want to know if we got here a different way. Fortunately, every single exception has a parameter property called was thrown from throw statement. So we can just check that to find out if we got here accidentally. So if it was not, we got here accidentally, and then I can log that, set the error message that this is an unhandled error. I can do my normal error log to get that to happen. And I also want a little bit more information about how this happened. In the error record itself, there is a property called script stack trace, which can tell you more exactly where an error occurred. So it can say it happened on this line within this function, which was called by this other function, which was called by this module, which is called by this other thing within this script. And so you get to see all those layers that can help make it a little easier to understand where the error happened. And so I won't grab that information often. But I will grab it in this case of an unhandled error. One gotcha there. Script stack trace is multi-line. So if you're looking at this in Excel, by default, when you open it in Excel, you'll only see the first line, and you'll need to make the row bigger in order to see the full stack trace. All right, now let's talk about the finally block. Why do we use a finally block? Because and for a long time, that confused me. Why would you use a finally block? Why don't you just put the code that comes after everything else? Why would you put it in a finally block? Well, the magic of the finally block is the finally block always runs. If PowerShell still exists, the finally block always runs, no matter what. And so it's a great place to do cleanup. Things that always have to happen. So then, like if I need to change my error action preference back, like I said before, I'll capture it at the top, and I'll set it to what I want it to be, and then I'll change it back in the finally block. And so then going through the try block, if something happens and it doesn't get all the way through the try block, it always skips down and runs the finally block. No matter what, if you hit Control C, it jumps down and runs the finally block. If you get errors and things all over the place, once it's done with the catch block, it jumps down and runs the finally block. Anything that interrupts the script, it's going to run down and run the finally block. The only times it won't do that is if it can't do that because it no longer exists. So if you hit the red X, you're out of luck. If you've got a scheduled task and you kill the task, you're out of luck. If you go into Task Manager and you kill the task, you're out of luck. But if PowerShell still exists, the finally block always runs. Even if there's a return statement up above, if in your try you do a return, before it does that, it jumps down to the finally block and runs that before it returns the data to whatever called the function or script. So so here's one example for cleanup where in our function, we create a session to Microsoft Exchange, and then import the session, and then we do get mailbox, and then we return how many mailboxes there are. We just count them. That's all this function is for, is to count how many mailboxes we have. But that, if I'm at a large organization, that leaves a huge amount of stuff in memory, in this open session with Microsoft. And if I were to run this function again, it would create a new session to Exchange, and then I run it again. It creates a new session to Exchange, and then I run it again, and then it fails because you're not allowed to have more than 3 sessions. So we want to clean that up. Most of the time, we don't worry about cleaning stuff up in PowerShell. We don't care. Stuff goes away when the script goes away. .NET garbage collection takes care of a lot of stuff in memory, but once in a while we care. Sometimes there's stuff that if our script is continuing, that we want to make sure that we get rid of. And so in this case, I've got the finally block, which always runs. So first, I'm going to clear out the mailbox variable. Now those aren't used, and the garbage collection will clean those up when it needs to. We remove the module from memory and we kill the session so that we can recreate it as many times as we want. And so if we got a bazillion mailboxes and someone's running this, even if they, if they get tired of waiting, they hit Control C to kill it so it stops. We're still going to jump down to the finally block and finish everything. And we can demo that. If we have a try catch finally, runs for 60 seconds, or hit Control C, it still runs the finally block. All right, now, if you do any research on error handling in PowerShell, you're going to be confused by stuff that comes up about the trap statement. Because early PowerShell blogs are going to talk about this is how you do error handling. Later blogs are going to say you don't use trap. That went away after PowerShell 1. But trap is still out there. Some places will say it's deprecated, but it most definitely is not. And you can search for about trap and get help and find stuff about it all over the place. Trap is what they built in PowerShell 1 when we didn't have try catch yet. And it was sort of kind of replaced by try catch when try catch came out. But there are still a handful of scenarios where you need a little bit of functionality that trap has that try catch does not. For example, the scenario try catch where we write to the log, we 1 divided by 0, write to the log, 1 divided by 0, write to the log. Then we have a catch. If we try that, all we get is the very first start process and the very first response and nothing else, because it skips the whole rest of the try block. The trap, on the other hand, doesn't do that. Trap, basically you could think of it as defining the catch block in advance, and then if you get an error, it runs that catch block, and then instead of skipping everything else, it goes on to the next line. It does not rerun the line that threw the error, but it does go to the line immediately after that. Just like try catch, we can also trap by particular types of errors. So we define the trap. Then if we run the rest, we go. Well, that wasn't expected. We do it well. We do it by running a continue. Continue is what tells it to go on to the next line. Today. Run the way I was thinking it was going to. Oh, that's why. Can't do it one at a time. You can't run a trap block and then run everything else. It has to be in the same session. So if we run all of it at once, then it acts as expected. We get the start process. We go down to we throw the error and go to the catch block, which gives us infinity. Continue tells us to go to the next line, so we log that. Throw the error, then go to the next line and get that. So, and that's why I use trap, is so that you can go on to the next line like that. Most of the time, try catch is the better option, but sometimes you need to do this. All right. Now we're at 8 o'clock, which is when you all normally stop, but I tend to be long-winded. And so if you have to go, you have to go. But if you want to keep going, I'm going to keep going, as long as there's somebody here listening. And we don't have a whole lot more. In fact, yes. In fact, this is the last thing. This is just a big monster example, and actually, this is much simplified. So this is 120 lines. This is a highly simplified version of a 12,000 line script that in real life. So up at the top, we set the error action, capture the error action preference and set it to stop. Got my master try catch block. And then I've got a nested try block where I import my modules. If that doesn't work, I can't continue. So I log that and then rethrow the error to jump to the end. Then I try to get my users. If that doesn't work, can't run the rest of my script without my users. So I log that, jump to the end. And I actually have fairly recently started using, if I'm doing this a lot, if I'm just doing this a couple times or in big enough chunks, I'll do it like this. But if I'm wrapping every single line, which you sometimes end up doing, I've got a better way to do that now. But not sure if I can show you that. I don't think it's been redacted yet. But in big chunks or just a few chunks, so to do this a lot. Sorry, where were we? Get users. Then after the users, I set some initial flags, and then I loop through all my users. And so for each user, I do stuff to the user, and I increment that flag. If it fails, I write it to the log, and I increment the user error flag. And then obviously in real life, there was more stuff there. And then I've got catch block where I do two things. One, I set an exit code, which I will show you later what that does. So if I haven't come here, my exit code by default is going to be 0. If I do end up at the catch block, it gets set to this. I do want to point out up above here in the user thing, I'm not rethrowing these errors. If a user has an error, I log that individual user error, but it's not breaking my script. I still need to process the rest of my users. So that type of error is not going to send me to this catch block. This is only for if the script as a whole failed and wasn't able to do what it needed to do, not user by user. The other thing I do in the catch block is I check to see if it was thrown from a throw statement, or rather not thrown from the throw statement. Did I get to this catch block accidentally? And if I did, I'm logging an unhandled error, and I am logging the script stack trace so I can figure out what the heck happened and how I need to fix my error handling so that that doesn't happen again. Then at the bottom, I've got a finally block, which I'm not just using for cleanup. I'm also using that for sending a status email to the end user, or to, I don't know, somebody gets the, yeah. Babbling here. Yeah, sending the final status email to whoever this gets sent to. So if we had an error message, I start the body with error. If otherwise, I set it as success. Put the error message in it if there was an error. Building this as this one I'm building as plain text. In real life, I'll usually build these as HTML. Make them pretty, because it's relatively simple to do. Set up some nice tables for the end users. Makes it nice, easy to read, easy to understand. So we use PowerShell 4s to make things easier for users. So anyway, then I just have notes in my email about how many users were done, how many had errors. In real life, I'm going to have little tables that shows more details. These were the users that were done, and then these were the users that had errors, and these were the errors they had. So that someone can then go fix whatever they need to fix in order for those errors to go away and for those users to be handled correctly the next day. And then my send mail message is wrapped in a try catch. So that I send that email out to the appropriate list of people, and if that fails, I just log that I couldn't send the email. You need to be real careful in your finally block, because you don't want to throw any errors in your finally block, because if you have errors in your finally block, then that's the end of your script. You won't have yeah. So you have to be sure all of your statements are simple, careful ones that can't possibly throw an error. Anything that could possibly throw an error, you would throw in a try catch. Otherwise, you won't get the rest of your finally block, which is important. As we've got our cleanup, which we're doing, and then we've got this command down here. And the reason we're doing this is because we've for those of us from the ops side of the house, we've all had that circumstance where you've got a PowerShell script running as a scheduled task out on some server, and you suspect that there's some problem, and that doesn't seem to have run, and then you go look at task scheduler, and task scheduler says that it completed successfully. And you're like, what the heck? You can't possibly have done that. It didn't run. But that's, of course, because as far as the task scheduler is concerned, it successfully ran PowerShell. It has no awareness of what happened inside of PowerShell. But this is how we can pass that awareness back up to task scheduler or any other thing, Jenkins or whatever, anything that you have triggering scripts. You can send feedback to. And the way you do that is by sending an exit code. And so up above here, if we had an error, we set the, the type of error we want to kill the script for. We set the exit code to 0xbad, which is just hex for 2989. And I choose that one because in task scheduler, the error code shows up in hex. But the default error code, or generic error code, is just 1. Because you can set the error code to anything you want. 0 is success, anything else is an error. And normally a non-specific error is the standard is to use 1. But in task scheduler, that's just going to show up as 0x1, which isn't necessarily going to pop out at someone looking at that as, hey, there's an error, something broke. Whereas if it shows up as 0x capital BAD, then something's wrong here. So I like to use that one. Now, in theory, if you want, you could use your error handling to use different exit codes for different types of errors. But this is almost never worth doing. If you're using with task scheduler, I would say it's never worth doing, because it would only be worth it if someone is going to look at task scheduler and see that error code. B, that person is going to know what that error code means and what to do with it, how to distinguish it from the others, how to respond to it. And C isn't going to just immediately go and open the log to get more information anyway. So if they're going to do that, they can just get that data from the log. Because it takes a lot of effort to come up with a scheme for doing this, and then to implement it in your code, and then to maintain it in your code. So in those circumstances, it's almost never worth it. Where it might be worth it, for example, is if you have a system, like Jenkins or some other enterprise scheduling system that has functionality for responding to various error codes. So for example, if it gets, if you can set your scheduling system so that if error code 2 comes back, it sends a text to whoever's on call, and if it gets a 1, it ignores it. If it gets a 3, it wakes up everybody in the company. Then if you've got some big important thing that runs in the middle of the night, then you can take the time and effort to instrument your error handling so that it gives a more a specific, meaningful exit code. Otherwise, it's almost never worth it. Just use the 2989 to do it. So that's pretty much my talk. Let me find for you where the heck you can get this code. Normally I just turn to someone else in the room. There we go. I will figure out where else to put it, but there's a place for the St. Louis group, but the Minnesota group has a GitHub called MN PowerShell group /meeting notes. And all of this code is there in, we're not bright enough to give the, where was it? Yes, in the 2018-10. Now let me put this over in the here. So I'm assuming everybody is asleep or have family or things, but does anybody have any last questions before we go? 9 people still hanging on. Well, you're welcome, everybody. Thank you for listening. I love any excuse to talk PowerShell. Anytime, anywhere. So we can stop that. So thank you all for coming. If you're ever in Minnesota, stop by us. Find us on Meetup, Minnesota PowerShell Automation Group. And next time I'm passing past St. Louis, I'll see if I can stop by and see you all. So I'll wait 1 more minute because of the lag to see if there's any more questions, and then we'll call it a night. And my phone is buzzing, so I assume my wife is trying to get me, wondering where the hell I am. Thanks again, everybody. Send me an email if you have any questions. Need to follow up. Talk to you next time.